Welcome to official channel of Department of ECE and EEE of the Dronacharya Group of Institutions, Greater Noida. I am Ruby Shaw and this video provides an introduction to power electronics. What is power electronics? Power electronics is the conversion and control of electric power from one form to another using semiconductor devices. Conversion of electric power is required when the load and the source are of different nature. For example, mobile phone. It is powered by a battery which utilizes DC power, and it is charged using AC supply at our homes or offices. Therefore, a converter is required to convert AC power into DC power, which is the mobile phone charger itself in this case. Control of electric power is required when we have to match the power, voltage and current levels required by the load. It is also required for variable frequency operation. Let us check an example of voltage level matching of load and source. Take the example of mobile phone charger again. The battery in a mobile phone works at 5 volt, whereas the supply available is of 220 volts. Therefore, the voltage must be stepped down to charge the battery. Let us see what are the various power conversions available. Various power conversions are AC to DC, DC to DC, DC to AC and AC to AC. Electronic devices and gadgets like TVs, mobile phones, laptops, etc. work on DC, but power source available at our homes are AC. We need to convert AC power into DC power, and for this purpose rectifier circuits are used, such as mobile phone chargers, adapters, SMPS, etc. Rectification is also required in HVDC transmission, where the AC power is converted into high power DC before the transmission. Next type of conversion is DC to AC conversion. We have noticed that during power outages, we use inverters at our homes. We have a battery which delivers power to our homes, which provides DC power. But appliances at our homes needs AC power. Thus, DC to AC conversion is required and is achieved using inverters. DC to AC converters can also be found in UPS, solar inverters. We know that solar power generates DC power. And also in HVDC transmission, where we have to convert the DC power back into AC power before final utilization. Now we see that there is another type of conversion, DC to DC conversion. Both the load and source are of DC in nature, then why this conversion is required? The DC to DC conversion is required to match the voltage level of the source and the load. It is used using choppers. Few applications are electrochemical processes such as electroplating, anodizing, metal refining, and chemical gas production. Similarly, there is AC to AC conversion. In AC, we can control the amplitude and the frequency. For controlling the amplitude, we use AC voltage controllers, and to control the frequency, we use cycloconverters. Now let us see what are the various applications of power electronics. Power electronics is used for motion control of electric drives. In electrical drives, precise control of speed and position of the motor is required. We find electric drives in elevators, escalators, amusement park rides, etc. Other application of power electronics can be found in electric and hybrid vehicles. In electric and hybrid vehicles, the power source is a battery bank which supplies DC power, and owing to their inherent properties, AC drives such as PMSM and BLDC are used in electric and hybrid vehicles. Also, the voltage and power level required by the drive is higher than the available in battery bank. In addition to this, the drive must operate at variable speed also. Therefore, not only a DC to AC conversion is required in electric and hybrid vehicles, but a power and voltage boost is also required. All these things are done using power converters only. Apart from this, power electronic converters can be found in smart grids, reactive power compensations, pumps and compressors, arc furnaces, induction heating, transaction application, and many others, to name few. The heart of power converters, that is rectifiers, inverters, choppers, AC voltage controllers, cycloconverter, is a power electronics device. These are semiconductor devices that works either in on state or off state. The working of power electronic devices is similar to electronic devices such as diode and BJTs. These devices exploit the cutoff and saturation region of characteristics and not the active or linear region. Power electronic devices can handle a large amount of power, unlike diode and BJTs, which typically work on low DC power in the range of 5 volt or so. Power electronic switches, on the other hand, can handle several kilovolts of voltage and several kiloamperes of current. These are control switches, and few examples of power diode are power BJT, power MOSFET, SCR, IGBT, etc. So the study of power electronics in nutshell includes the following: study of principle of operation, characteristics, drive circuits, production of various power electronic devices, and study of configuration, principle of operation, characteristics of various power converters, and last, study of various control strategies of the power electronic devices and various power converters for different applications. This is all for this video presentation. Thank you for your time and keep looking for more videos on power electronics. Thank you.